Hi everyone, myself and Arun Kumar from Essence College of Technology in the Department of ECE. In this video, we are going to see about low power IC design. Under low power IC design, we are going to see the need for low power circuit design. While designing an IC, the power factor is the essential factor for designing an IC because the ICs are normally having a small size. If you are passing the power supply to all the ICs, then it requires some low consumption so that we are making an IC as a low power one. So one of the factor which can define the ICs and their power factor by using packages is Moore's law. So the this kind of information has been provided with the help of this Moore's law. The most important aspect of Moore's law is it become a universal predictor for the growth of the entire semiconductor industry. In VLSI design, small area and high performance are the two conflict constraints because all the ICs are manufactured with the help of packages. So in the package, it just consume about small area and high performance of the concern IC. So in order to making the IC in a proper format, we need to constrain that above two factors. From Moore's law, it understand that the number of devices in a chip doubles every 18 months because nowadays we are using a smartphone as well as the smart TVs. So it's under comes under VLSI, very large scale integration unit, because all the ICs are having in a single package based on the compact sizes of the usages of the particular informations, so that we are focusing about the power factor as well as the size of the concern ICs. So the Moore's law shows that how the ICs are manufactured, or how the ICs are combining with the help of packages. Nowadays, we are using AMD processor with respect to Intel processor. So this graph shows that Intel processor has been compared with AMD processor. So the two factors they are defining in this two processor. First one is power factors and second one is size of the concern ICs. These two packages has been defined by using these two factors. So in 1970, they are using 80s processor, 80, 85, 86, and it can be upgraded to Pentium processor like Pentium Pro, Pentium 2, Pentium 3, Pentium 4, and dual core processor, core 2 dual processor. In single processor having two processor inside the chip, after upgrading core to Duo processor, then it may be forwarded by core to quad processor. Four processor are in same ICs. And next one is core i7 processor. Nowadays we are using core 10 processor also. Nowadays the core 11 also is coming nowadays. So the only thing is cost factor. While comparing the Intel processor with the AMD processor, the AMD is a low cost factor, and the graphical resolution of the ICs are high level processing speed when compared with core processor. On comparisons, Core 9 i7 processor are compared along with their prices. Here they are using Core 9 as well as the Ryzen AMD processor. So the price of the concerned processor will be 49 to 50k thousand AMD processor. The Intel processor they are having a 54 to 62 thousand processor. So like that, all the previous processors are having a less amount when compared with the new level upgradation process. While considering the processor, we need to check the following factors. First one is the CPU and CPU clock speed, cache memories, and next one is RAM speed, and also the graphic processor support. These are important factors while considering a processor, especially for upgradation processor. We need to check all these parameters in upgradation manner. For example, if your clock speed is lower than your CPU, means then automatically you can't get your original resolution, or can't get your original processing speed. And moreover, your RAM speed also high, because the RAM is the random access memory, read-only memory. Random access memory also very useful to check the speed of your processor. And next one is the core memory. Core memory is having a cache memory. The cache memory is very useful to store the buffering value of the speed of the your system. It is a transparent memory which can be shown about your processing speed as well as your transition data. While using the low power design, we need to focus DC current supply, especially for DC current and leakage current are the source of the static power. And next one is dynamic power is using a frequency dependent, which comes from the transistor switching and short circuit power. So there are some two factors while defining a low power circuit design. One is static, and another one is dynamic. In static, they are using speed as well as the processing level of the concerned ICs. And dynamic, we can able to check the power constraints. Next one is dynamic and static power characteristics of CMOS. CMOS is the source for making an IC with the more compact power factors, because they are having a NMOS and PMOS inside the medium. While giving the input voltage to the CMOS, automatically it may pass to the PMOS as well as the NMOS. Then the corresponding voltage can be stored in C out, so that we can able to catch the output voltage from the above two terminals. So here the low power constraint has been forwarded from this base to dynamic process. The low power design can reduce the total power consumption by controlling the supply voltage, reducing the circuit complexity and clocking frequency, and as well as the DC current sources of the concerned medium. So need for low power circuit. First one is system specialization, because you are going to making your IC as a compact one. So we need to clarify your system. And second one is system design level power estimation. Based on your ICs, we need to check the power constraints of the concerned ICs in the package. And next one is architectural design level power estimation. Your power constraint must be adaptable by the packages. So we need to check the design level. And next one is logic design level. Your packages must be able to forward your output to the next level by using a logic design. And next one is circuit design level power estimation. The power has to be forwarded to the destination without any distortion. After getting all the information by using the circuit, we need to check the physical design by, by applying a power estimation methods. Assessment, how to optimizing the ICs design for low power. So there are some three factors which will be included to making an IC in a proper power supply. First one is portability, second one is high performance, next one is reliability. If we need to focus about these things, we need to get proper power supply for all the IC terminals. Thank you.